You know, there's this invisible revolution happening literally all around us. It's on the tools we use, the buildings we live in, and yeah, even inside our own bodies. We're talking about a technology of microscopic shields, this unseen armor that's making our world stronger, smarter, and way more durable. So what exactly is this stuff? Let's dive in.
Okay, so this sounds like the beginning of a really weird joke, right? A dental implant, a highway that glows, and a plain old t-shirt. But the answer connects all of them, and it's this amazing technology called advanced surface coatings. And listen, these aren't just simple layers of paint. We're talking about seriously engineered materials that give ordinary objects these extraordinary new powers.
To really get why this is such a big deal, we first have to understand the enemy. See, everything around us is in this constant, invisible fight against decay. Materials break down, they get worn out, they fail. It's a universal problem that costs us, billions of dollars and puts safety and efficiency at risk every single day.
We've all seen it. Rust, that relentless, creeping corrosion that just attacks our infrastructure, our cars, anything made of metal, really. The moment steel gets exposed to the elements, especially something as nasty as seawater, it kicks off a chemical reaction that just eats away at the material, weakening it from the outside in.
And then you've got just plain old physical wear and tear. Think about the friction on a massive industrial cutting tool, or the constant grinding that happens inside a medical implant. Every single movement, every point of contact, is slowly but surely grinding away at those surfaces, which shortens their lifespan and makes them less effective. This mechanical breakdown is a huge reason why we have to keep replacing things. And sometimes the biggest failures, well, they start small. I'm talking tiny, microscopic cracks that start to form in materials like concrete. At first, you'd never even notice them. They're harmless. But over time, with stress and exposure, these little microfractures grow, they connect, and they can lead to a sudden catastrophic failure. This is the invisible battle that's happening all the time.
So here's the key takeaway from all this. Whether it's rust, wear, or cracks, the failure always starts at the surface. And that is exactly where the science of advanced coatings comes into play, offering this incredible microscopic shield to fight back against all those forces of decay.
So, what are we really talking about here? An advanced surface coating is not just paint. It's this incredibly thin, super high-tech material, often made of multiple, distinct layers, that's been specifically engineered to completely change how a surface behaves. It can make something stronger, or slicker, or even smarter. And the versatility here is just astounding. We're talking about beefing up everything from the steel in our bridges and the titanium alloys in our dental implants, to the concrete in our buildings, lightweight magnesium, natural wood, and even the textiles we wear every day. Okay, so what kind of superpowers can these coatings actually give a material? First up, let's look at the most obvious benefit, giving it the ultimate physical armor. This is all about giving materials superhuman protection against the forces that are constantly trying to destroy them. Let's go back to that problem of wear and tear for a second. Industrial machines, medical parts, they face extreme friction and abrasion day in and day out. This constant grinding really limits how well they work and how long they last. So what happens when we apply one of these specialized coatings?
The results are, well, they're dramatic. In one study, a special two-layer coating put on high-speed steel cut down physical wear by more than 90%. That's like making a tool 10 times more durable. Just think about it. Fewer replacements, less industrial waste, and huge cost savings, all from a shield that's basically invisible.
And you see that same incredible level of protection against corrosion. You drop uncoated steel in seawater and it rusts fast. But with a specialized coating, the whole process slows way down. The coating basically acts like a force field, a barrier that stops the corrosive stuff from ever even touching the metal underneath. Now, to measure just how good this protection is, scientists use a metric called polarization resistance. For one particular composite coating on carbon steel, they recorded a value of 114 kiloohms centimeters squared. Now, you don't have to be an engineer to get this. All you need to know is the higher that number, the stronger the shield is against corrosion. It's hard data showing just how protective these layers are.
But protection isn't just about fighting off friction and rust, right? What about something like ice? Ice buildup is a massive problem for everything from airplane wings to power lines. It's heavy, it's dangerous, and it's a pain to get off. But what if the surface just refused to let ice stick in the first place?
Well, the results are pretty amazing. An icephobic, which means ice-fearing, gel coating can reduce the force you need to remove ice to almost nothing. We're talking around 8 kilopascals, which is just incredibly low. And this isn't a one-and-done trick. Even after 25 cycles of freezing and thawing, the coating works just as well. The ice basically just slides right off.
But sheer toughness is just the beginning. The next generation of these coatings is even more incredible. They're not just passive shields anymore. They're active, responsive, intelligent systems. We're talking about surfaces that can actually think.
I know, this sounds like it's straight out of a sci-fi movie, but it is becoming a reality. Just imagine a scratch appearing on a surface, and then, a few moments later, you just watch it disappear as the material fixes itself. This is the mind-blowing promise of self-healing coatings.
So how in the world does that work? Well, the coating is embedded with millions of tiny microcapsules that are filled with a healing agent. When a crack forms, it breaks open the capsules that are nearby. The healing agent, in this case it's glycerol, is released. It flows into the crack, fills the gap, and seals the damage. It is a brilliant, totally autonomous repair system that stops tiny problems from becoming big ones.
And when we're looking for these kinds of smart solutions, where better to turn than nature itself? I mean, for millions of years, nature has been perfecting materials. So now, researchers are taking inspiration from the natural world to create coatings that are more effective and more sustainable.
For instance, by using aloe vera gel as an agent in coatings for textiles, we can seriously increase a fabric's resistance to abrasion. That means your clothes last longer. Or how about this? By putting tea tree oil into a coating for wood, we can give that surface powerful, long-lasting antimicrobial properties, protecting it from stuff like mold and bacteria. And the intelligence just keeps on coming. Get this. How about a highway that lights itself up? Researchers have developed a luminescent coating that has these special phosphors in it that absorbs sunlight during the day. Then, for over 8 hours after the sun sets, the coating releases that light, creating this visible glow. This could completely revolutionize road safety, especially in rural areas with no streetlights.
So, when you pull it all together, what does it all mean? Well, from making tools last 10 times longer to creating self-healing surfaces and glow-in-the-dark highways, it's clear we're entering an era where the fundamental nature of our materials can be completely re-engineered, one surface at a time.
When you look at the big picture, the benefits are just massive. We're seeing huge gains in durability, so things just last longer. We're making things safer with stuff like self-lighting roads and more reliable medical implants. We're boosting efficiency by cutting down on friction and wear. We're making things more sustainable with these nature-based solutions. And we're literally embedding intelligence directly into the materials that build our world.
This technology really does give us the power to grant almost any surface of superpower. We can make them tougher, slicker, self-healing, maybe even self-aware one day. And that leaves us with a really fascinating question to think about. Now that we can engineer this surface of pretty much everything, what big challenges should we solve next?